let's start off by reviewing the elimination method for solving systems of equations. And that's always done by taking the two equations and essentially adding them together. Before we actually get into some examples, I wanted to talk about the reason that this procedure makes sense. But say, for example, I have one equation that makes sense, a is equal to b or whatever. If an equation is a true equation, that's meaning that whatever's on the left side and whatever's on the right side, those must be the same thing. They must be equal in value. If I have a secondary system of equations where c is equal to d, whatever those two things are, if I'm also claiming those are equal to begin with, basically what I have is two completely different equations which are a statement of equality. If I actually add those things together on both sides, which is how elimination works, it's kind of like I'm going to add the two left-hand sides together, a plus c, and I'm going to add the two right-hand sides together, b plus d. What I would get is another new true equation that is also must be true. And this makes sense because if I'm thinking about this new equation, a and b are equal in value by my first equation, and c and d are equal. So if I'm thinking about an equation as a system of balances, the first equation, a is equal to b, those things are both in balance. And c and d are different, also in balance. If I add those two different things together, since they're both in balance, the new equation is different, but it's also in balance. It's still true equation. So what all this means is when I add equations together, I'm not changing the trueness of my equations, and we can use that to our advantage to actually solve an equation. So let's apply that to a particular system, like example number 1 from the packet. So if we take this equation and we add it together, what I have is the first one says x plus y equal -1, and the second is 2x minus y equals 7. And my goal is to figure out, well, what is that coordinate xy point that makes sense in both? But if I add them together first, basically I'm going to take the entire left-hand side, and based on the alignment, what we can combine like terms. So x plus 2x makes 3x, and y minus y makes 0. Or we often refer to this as elimination because those ones will eliminate each other, which if you're doing elimination correctly, one of your variables should cancel. And the reason why we want a cancellation is if we cancel one of the variables, we are allowing ourselves to find the other. And then the last part, -1 plus 7 is 6. So when I perform the addition property of equations, I get a new equation, which again, this must also be true because of everything I was just saying. But what I could then do is solve this much simpler equation by dividing both sides by 3, and what I would be led to the conclusion is that x is equal to 2, which is part of our answer. Basically, in our solution, x must be 2 by this train of logic. But since our goal is to figure out the xy point, we know that x is 2, but we don't know y. So the next part is what we often refer to as back substituting the answer back in. So once I know that x is 2, I could revert back to the original system, because to reiterate, both of those original equations must be satisfied. I could then plug in x into any one of them. I could use either equation 1 or 2. I would always suggest plugging into the simpler equation, or whichever, you can just do whichever one you think looks better. If I plug x back in, or back substitute that in, what I would get is a simple equation. I already know x, I could then find y, because once I have one of them, the other one is my only final unknown, and then I could subtract 2 from both sides to find y. And this should be the solution to my system by using the elimination method. And I could always check by back subbing it in, the entire point into both equations as I did above to make sure. But assuming I didn't make any mistakes, this has to work. And let's just check it out. 2 minus 3 is indeed -1. That works in the first. And in the second, 4 minus -3 is +3, so 4 plus 3 is 7. Yes, this makes sense, and I have found my solution.